Hello students, this is a video lecture on some topics of module 3 in software engineering and project management. Mainly we'll be talking about the design phase of software development life cycle. The content for this lecture are introduction to design phase, design process, design principles and design concepts. Introduction to the design phase. Design phase is the phase that comes after requirement analysis and specification. That is, we have uh, gathered the requirements and have analyzed the requirements and specified it. Now we are moving into the technical activities. That is, we are going to design, generate code and test it. That is the technical activities, and the software design is the first of these three activities that are required to build and verify the software. So design is basically a meaningful engineering representation of something that is to be built. So here we are going to develop a software or build a software. So design here creates a representation or model of the software, and it can be traced to customers' requirements and at the same time assess for quality against a set of predefined criteria. So the importance of software design can be stated with a single word quality. The design is the place where the quality is fostered in software engineering, and it provides us with the representation of software that can be assessed for quality. Design is the only way that we can accurately translate a customer's requirement into a finished software product or system. Actually, it acts as a bridge between the software requirement or the specification of software requirements by the customers and the finished software product or system. So the software design serves as a foundation for all the software engineering and software support steps that follows. And in software engineering context, the design focuses on four major areas of concern. That is data, architecture, interfaces and components. So using the design task or in the design phase, it is going to produce a data design, an architectural design, an interface design and a component design. So each of the elements of the analysis model, which we have already seen in the last module, is going to provide or it provides the information that is necessary to create the four design models required for a complete specification of design. This flow of information during software design is illustrated in the given figure. Software requirements manifested by data, functional and behavioral model feed the design task. Using one of a number of design methods, the design task produces a data design, an architectural design, an interface design, and a component design. That is shown here. That is here. For example, if we take a data design, the data design gets information mainly from the entity relationship diagram and the data dictionary. The arrow mark represents that information flow. Otherwise, if I take component level design in the design model, it gets the information from the process specification, from control specification and state transition diagrams. So this is how the information from the analysis model is used to develop the um, design model. Now we will see detail about different types of design. First one is the data design. The data design transforms the information domain model created during analysis into the data structures that will be required to implement the software. The data objects and relationships defined in the entity relationship diagram and the detailed data content depicted in data dictionary provides the basis for the data design activity. So basically in the analysis model we have the entity relationship diagram as well as the data dictionary with all the data contents, and that is used as the basis for this data design activity. And a part of this data design may occur in conjunction with the design of software architecture, and more detailed data design occurs as each software component is designed. Then we have architectural design. Architectural design defines the relationship between major structural elements of the software, the design patterns that can be used to achieve the requirements that have been defined for the system, and the constraints that affect the way in which the architectural design patterns can be applied. So, the architectural design representation can be derived from the system specification, analysis model, and the interaction of subsystems defined within the analysis model. So, it is basically a framework of a computer based system. Okay. Basically, we have to develop a framework of the system during the architectural design, and this is derived from the system specification, the analysis model, and the interaction of subsystems defined in the and within the analysis model. Then we have the interface design. Interface design describes how the software communicates within itself with systems that interoperate with it and with humans who use it. An interface implies a flow of information and a specific type of behavior. Flow of information include data flow as well as control flow. Therefore, a data and control flow diagrams provides much of the information required for interface design, which is again available in the analysis model. The data flow diagrams and control flow diagrams are available. This information will be used to develop the interface design of the system. And finally, we have component level design. Component level design transforms the structural elements of the software architecture into a procedural description of software components. Now we have the structural elements. Now we need to convert it into or transform it into some kind of procedural descriptions, and this information is obtained mainly from the process specification, control specification, and state transition diagram of the uh, analysis model to develop the component level design. So these are the different types of software design, and during this design we make decisions that will ultimately affect the success of the software construction, and as important, the ease with which the software can be maintained. And without this design, what happens, or what is the why it is required, is because if we develop a software without design, we are we risk building an unstable system that will fail when small changes are made, or one that may be uh, or one that may be difficult to test, or one whose quality cannot be assessed until late in the software process. That is when the time is short and we have already spent a lot of money on it. In such cases, it is better to develop a software with a proper design. Design process. So, software design is an iterative process through which the requirements are translated into a blueprint for constructing the software. Initially, the blueprint depicts a holistic view of the software. That is, the design is represented at a high level of abstraction, a level that can be directly traced to specific system objective and more detailed data, functional, and behavioral requirements. And as the design iterations occur, that is, as the design process is repeated again and again, subsequent refinement occurs, and these refinements leads to design representations at much lower levels of abstraction, and these refined designs ca- still can be traced to requirements, but the connection is more subtle. Throughout the design process, the quality of the evolving design is assessed with a series of formal technical reviews or design walkthroughs. Mainly three characteristics serves as a guide for the evaluation of a good design. That is given here. First one is the design must implement all the explicit all of the explicit requirements contained in the analysis model, and also it must accommodate all the implicit requirements desired by the customer. All the explicit requirements that is explicitly provided by the customer should be implemented, as well as there will be some requirements or some characteristic for the software that we are going to develop which is implicit to it or which must be there in that system, that also must be implemented. That is the first characteristics for a good design. Then second is the design must be a readable, understandable guide for those who generate code and for those who test and subsequently support the software. So anybody who have to work with the same software in later time, like the person who is going to test it or subsequently who is going to support the software, everyone should be able to understand the design and it should be readable. That is the second characteristic. Then third is the design should provide a complete picture of the software addressing the data, functional and behavioral domains from an implementation perspective. So this design should give you a complete picture of the software, or while seeing the design you should understand what is going to be its functional behavior, or what are the information that's going to be in the software, and what is going to be the behavior of the software. So each of these characteristics is actually a goal of the design process. In order to evaluate the quality of a design representation, we must establish some technical criteria for good design. So there are mainly 7 technical criterias for a good design that is given here. first one is the design should exhibit an architectural structure that has been created using recognizable design patterns, is composed of components that exhibit good design characteristics, and can be implemented in an evolutionary fashion, thereby facilitating implementation and testing. So it should have a architectural structure which is going to have these three characters. That is, it should be recognizable design pattern, it should composed of components uh, that exhibit good design characteristics and can be implemented in an evolutionary fashion, uh, facilitating implementation and testing. Then second technical criteria is a design should be modular. That is, the software should be logically partitioned into elements that perform specific functions and subfunctions. Okay. Then third technical criteria is a design should contain distinct representations of data, architecture, interfaces, and components. That's what we have already seen. That is, there should be four types of design which shows this, which is distinct representation of the system. That is data design, architectural design, interface design, and component design. So it should be there. Now, fourth design or technical criteria is a design should lead to data structures that are appropriate for the objects to be implemented and are drawn from recognizable data patterns. That is, there are different information different data objects and the relationships will be identified. This design should lead into development of data structures which is appropriate for the objects that we have uh, found, and it should be drawn from some kind of from recognizable data patterns. Then fifth technical criteria is a design should lead to components that exhibit independent functional characteristics. That is, we are dividing the system into different modules or different elements, and these elements should have independent functional characteristics. Then sixth technical criteria is a design should lead to interfaces that reduce the complexity of connections between modules and with external environment. That is, you are developing software with different modules. There will be some kind of connection between the modules, but when we are developing different modules with connections or with interfaces, these interfaces should have less complexity, or we have to reduce the complexity of this connection between the modules and also with the external environment. And the seventh technical criteria is a design should be derived using a repeatable method that is driven by information obtained during software requirement analysis. That is, the design process should be an iterative process or a repeatable process that during each of these iterations you are going to uh, refine the design into a more lower level of abstraction. So these are the different technical criteria. Now, the evolution of software design. The evolution of software design is a continuing process that has spanned the past 4 decades. Early, the design work concentrated on criteria for the development of modular programs and methods for refining software structure in a top-down manner. Then, the procedural aspects of the design definition evolved into a philosophy called structured programming. Later, The work proposed methods for the translation of data flow or data structure into a design definition. Newer design approaches proposed an object oriented approach to design derivation, and today the emphasis in software design has been on software architecture and the design patterns that can be used to implement the software architectures. Many of these design methods are being applied throughout the industry. Many design methods are being applied throughout the industry, and like the analysis method, each software design method introduces unique heuristics and notations. Yet all of these methods have a number of common characteristics. Uh, they are a mechanism for translation of analysis model into a design representation, a notation for representing functional components and their interfaces, heuristics for refinement and partitioning, and guidelines for quality assessment. Regardless of the design methods that is used, a software engineer should apply a set of fundamental principles and basic concepts to data architectural interface and component level design. These principles and concepts are considered in the sections that follow. Software design is both a process and a model. The design process is a sequence of steps that enable the designer to describe all aspects of the software to be built. The design model is equivalent to the architect's plan for a house. So, in the design model that is created for the software, it will provide variety of different views of the computer software. So, basically, the design principles enables the software engineer to navigate the design process. The design principles are given here. First one is the design process should not suffer from tunnel vision. That means a good designer should consider alternative approaches, judging each based on requirements of the problem, the resources available to do the job, and the design concepts. And second one is the design should be traceable to the analysis model, which means that uh, which is because a single element of the design model often traces to multiple requirements. It is necessary to have a means for tracking how requirements have been satisfied by the design model. Then, third principle is that the design should not reinvent the wheel. That is, the systems are constructed using a set of design patterns, many of which have likely been encountered before. These patterns should always be chosen as an alternative to reinvention. Time is short and the resources are limited. Uh, Design time should be invested in representing truly new ideas and integrating those patterns that already exist. Next design principle is the design should minimize the intellectual distance between the software and the problem as it exists in the real world. That is, the structure of the software design, whenever possible, should mimic the structure of the problem domain. Then, next design principle is that the design should exhibit uniformity and integration. That is, a design is uniform if it appears that one person developed the entire thing. Rules of style and format should be defined for a design team before design work begins. A design is integrated if care is taken in defining interfaces between design components. Then, next design principle is the design should be structured to accommodate change. That is the design concept discussed in next section enables a design to achieve this principle. The design should be structured to degrade gently even when aberrant data, events, or operating conditions are encountered. That is, a well designed software should never bomb, it should be designed to accommodate unusual circumstances, and if it must terminate processing, do so in a graceful manner. Okay. Then, design is not coding. Coding is not design. Even when the detailed procedural designs are created for program components, the level of abstraction of design model is higher than the source code. The only design decision made at the coding level address the small implementation details that enable the procedural design to be coded. Okay. Then the design should be assessed for quality as it is being created, not after the fact. That is, a variety of design concepts and design measures are available to assist the designer in assessing quality. So that should be used to assess the quality as it is being created. And then the design should be reviewed to minimize conceptual or semantic errors. That is, there is sometimes a tendency to focus on smaller things when the design is reviewed, missing the forest for the tree. That is, a design team should ensure that the major conceptual elements of the design have been addressed before worrying about the syntax of the design model. So, this is the design principles. When these design principles are properly applied, the software engineer creates a design that exhibits both external and internal quality factors. External quality factors are those properties of the software that can be readily observed by the users. And the internal quality factors are of importance to software engineers. They lead to a high quality design from the technical perspective. So to achieve internal quality factors, we have some kind of design concepts, and the designer must understand the basic design concepts for increasing the internal quality factors. That is going to be the next topic which we will see in the next video.